Welcome to the Disaster Management Lab. This is exercise number 1. The sheet that has been provided to all the students contains a question on the top, followed by seismograms of seismic stations, and that is followed by a map at the bottom. Now the question states that there are 3 seismic stations A, B and C, and for each seismic station the seismogram is visible, and using these seismograms the distance of each seismic station from the earthquake epicenter will be estimated. Using the triangulation method, the crustal velocities of P and S waves have been provided over here, that is 5.5 kilometers per second and 3.5 kilometers per second for P and S waves respectively. Now before proceeding to the exercise, everyone should have a basic understanding of how an earthquake is generated and what kind of waves are released during an earthquake. So here we can see that there is a seismic station on the surface, and then there is an active fault, and now we are going to see an earthquake on this fault. Here it goes, and this earthquake causes a part of the crust to sag down along this fault, and a lot of energy is released by this sliding, and P and S waves migrate outwards from this zone. P waves are faster than S waves, so the arrival of P waves is relatively earlier as compared to the S waves, and there is a time gap between the arrival of P and S waves. That time gap increases as the distance of the seismic station from the epicenter increases. So vertically above the focus, or the point where the earthquake energy has been released, there is the epicenter, and the horizontal distance from the earthquake epicenter to the seismic station needs to be estimated. Now if we know the horizontal distance for at least 3 seismic stations, we can use the triangulation method to pinpoint the location of the earthquake epicenter. Now we have to use this equation: D is equal to T divided by 1 upon Vs minus 1 upon Vp. So here D is the horizontal distance from earthquake epicenter, distance of the seismic station of course. T is the time gap between the arrival of P and S waves. Vs is the velocity of S waves, that is in our case we are assuming it to be 3.5 kilometers per second, and Vp is the velocity of P waves, which we are assuming as 5.5 kilometers per second. Now here is the seismogram from the 3 seismic stations A, B and C. In each of these seismograms, the x-axis represents time in minutes and the y-axis represents vertical ground motion, or the amplitude of earthquake vibrations. Here we can see that there are 2 different clusters of vibrations. So this particular cluster represents the arrival of P waves, and then here it represents the arrival of S waves. In each case we can see that there are distinct clusters of vibrations, and the difference between the 2 clusters represents the time gap. Now here we have to estimate the time gap between the arrival of the P waves and the S waves. So in this particular case of seismic station A, the arrival of P waves takes place at 3.05 minutes, and the arrival of S wave takes place at 4.75 minutes, and the difference between these 2 arrivals is approximately 1.7 minutes. Now putting this value of time difference in this equation, we get this is 1.7 minutes, so we multiply it by 60 because the velocities are in kilometers per second, so we have to convert it into seconds. So it is multiplied by 60 divided by 1 upon 3.5 minus 1 upon 5.5. This gives us an approximate value of 982 kilometers. So for seismic station A, the distance from the epicenter is 982 kilometers. Similarly, we can calculate the distances for the stations B and C. Now with this particular distance, we can move on to the next, that is the map. And in this map we have to first look at the scale, and now the scale may be somewhat different on the printed paper, because on the screen the dimensions may be different, but on the printed paper the dimensions may be different. So you have to measure the actual length of this bar, scale bar, on the paper. So this will give you, let us say for example, 1000 kilometers on the ground represents 3 centimeters on the map. So 981 kilometers will be equal to 3 into 981 divided by 1000. So this will be approximately 2.94 centimeters on the paper. Now using this distance on the paper, we will use a compass, and we will spread the compass with this distance, and we will put the needle of the compass at point A, and we will draw an arc using this distance. Similarly, for the distances that we have calculated for B and C stations, we will convert these distances from kilometers to centimeters and trace our curves for each station, and these arcs will intersect at one single point, and that will be the epicenter of the earthquake. Now to estimate the coordinates of this epicenter, you can just see it from the northing and easting values on the sides and bottom of the map.